everybody, welcome back to another Tuesday's Tech Talk, and I appreciate you guys dropping in and watching this every week. And this week we're going to talk about loudspeaker measurements, and we're going to look specifically at measurements that tell you a lot about how a speaker is going to sound, and measurements that we hear about often that really don't tell you anything about how a speaker is going to sound. And some of these are very telling, some of them are not. We're going to really dive into this thing, and hopefully you guys can learn a little bit about the measurement taking process and how to read the measurements, and what to realize is advertising catchphrases. And the first segment we're going to do is on the measurements that really don't tell you how a speaker is going to sound, and it is very much a marketing catchphrase more often than not. The two we're going to look at today are power handling and distortion measurements. And when you look at that from a loudspeaker standpoint, you always hear high power handling and low distortion. It's just become a catchphrase that's it started back in the 70s, even when I was a kid, and you still hear it today. It's kind of like the advertisement that you see for some speakers that are now digital ready, or they used to tout being made from bulletproof material, bulletproof Kevlar, or now they have carbon fiber. And one of my favorites was when they used to say they used space age technology, which to me was always funny. The space age obviously was late 60s, early 70s, so when you hear space age technology, you always think, okay, that's 50-year-old technology. So always makes me laugh when I hear that stuff. And kind of the same can be said for when you see power handling and distortion stuff thrown around. Power handling, used to, people would ask, how many watts are those speakers? How many watts are they? Or how many watts will they handle? And that always made me laugh. There's really no industry standard as far as measuring power handling. And power handling, when you break it down, has to be looked at in two different ways. Either it's thermal power or mechanical power. So there's mechanical limits of a driver versus its thermal limits, and they can be very much extreme. Mechanical limits is just how much power it takes for it to reach its X-max or start destroying itself. Like a tweeter, for instance, has very little excursion capabilities, and if you send a full range signal to the tweeter with no filter at all to remove the low frequencies, the low frequencies will obviously bottom out the little driver and just start tearing the voice coil off the former or something. It wouldn't handle 10 watts full power without burning itself up. And if you just send it a 20 hertz note, it would probably beat itself to death at a couple of watts. But thermally, it can handle a lot of power. It may handle 300 or 400 watt peaks without any issue at all. It just depends on how it's filtered and how you've removed the low frequency ranges from it. Same goes for little full range drivers. These are wideband drivers. You can send them full range signal. They'll handle about 30 watt music input with a wideband signal. But if you send them a 20 hertz note, you may beat them to death with 5 or 10 watts of power and tear them all to pieces, because they just won't handle that much power at that frequency. So think of power handling in a lot of cases as being frequency dependent. If you filter the lows out of this little driver and say you remove everything from 100 hertz on down, well, they can handle 100 watts of power and handle it pretty well, because the thermal limits is much greater than its mechanical limits. Same goes with any driver. You move up to a bigger, say 6.5 inch driver, the sweep area is much bigger, the X-max is much longer. It may handle 20 watts at 20 hertz before it reaches its limits, and it also depends on how it's loaded in the box. And things like that that help control the driver. The thermal limits, though, may be quite high. So long as you're sending it clean power, you're not clipping an amplifier, you're not going to hurt these things. Most speakers are the same way, and we've sold of our little 5 1/4 inch woofers and some of these 6 1/2s. I bet we've sold 10 or 12,000 of them over the years we've been in business, and I've never had one fail from a power related issue as far as wouldn't handle enough power. We never ever see that kind of a failure. Very rarely do we ever see a failure, and usually it's because someone clipped an amp on it, or their little 50-watt Denon receiver just wouldn't play it loud enough, so they just kept turning up the volume to the point where the receiver's clipping, and you start destroying the driver that way. And that's usually what tears one of them up, is you're just overdriving an amplifier. But so long as your power is clean, you're not going to have any issue. I know guys driving a lot of their speakers with 1200-watt ICE modules, and they'll produce a lot of power pretty cleanly, and so long as you've got clean power, you're fine. It's when you're overdriving those lower powered amps that's usually the problem. And a lot of the newer chip amps and things clip pretty softly, so that helps as well. But you just have to listen to what you're playing, and when you hear it distorting and you know you're at the limit of your device, whether it be your receiver or amplifier, know when to turn it down. And know when you see speakers advertised in watts, it's just marketing. If you see a 200-watt speaker or 300-watt speaker, the bigger number they put on it has nothing to do with how it's going to sound, and it really has nothing to do with the power handling. It's just marketing, and that's really common. And they do the same thing with distortion. There's no industry standard in it. No industry standard again, even in the power handling. Drivers are never tested to failure. One may fail at a certain wattage. Then the same driver may handle twice that much in another instance. It's not a point at which it just fails. It's just a generalization, and you have to take it as a generalization. Again, same with distortion. There's no industry standard on how distortions are measured, and anybody that gets a measuring system out there may have distortion measuring capabilities. That doesn't mean they can measure distortion. That doesn't mean they can get any meaningful data. One of those reasons is when you're measuring a driver, and let's say you're measuring an amplitude of 90 decibels. The average noise floor in the room may be 45 to 50 decibels. So that noise floor in the room is so low that it's not affecting the SPL capability of the driver. So you can measure amplitude without any issue. The amplitude is at 90 dB. The noise floor is down at 45, 50 dB. It's not affecting it. But when you're measuring distortion, the distortion that you're measuring is at that 1 or 2% level. It's 45 or 50 dB level if the driver's playing at 90 dB. So there's no way of really measuring that and separating it from the noise floor of the room. The noise floor of the room is at the same level as the distortion that you're trying to measure. So it's like trying to measure someone's voice in a crowded cafeteria full of a bunch of people. How do you measure that one person's voice from 50 feet away when there's a whole bunch of voices in the room? It's the same thing when you're trying to measure distortion. If you're outside of an anechoic chamber, you're just not going to get meaningful data. You almost have to be in a noise-free environment, in an anechoic chamber, to get real numbers that you can have any use for at all. There's several things people do to try and create a greater differential between the noise floor and the distortion that they're trying to measure. One way is just to play it louder, so that what you're measuring is louder than the room noise. But again, when you start putting more power on a driver, you are increasing its distortion to begin with. So with no standardization for what power levels you're feeding it, there's no real standardization as to how it's being measured. I mean, when you start powering this thing with 1/4 of a watt versus 100 watts, the distortion can be very different, and there's a lot of non-linearities that happen as the driver starts to move. And how do you measure that? You know, it's almost impossible outside of an anechoic chamber. The other thing people do in trying to get some kind of meaningful data is they'll get the microphone closer and closer to the driver. They'll get it right on the surface of the driver, and then the differential from the output of the driver versus the noise floor in the room can be greater. Therefore, you can get a little better handle on the harmonic distortions that might be present, but you're not away from it. And when you're measuring up close to the near field, you're creating a time differential between things that you're trying to see in the measurement. You may have cone breakup and different things going on and ringing that you're not going to see as much in the measurement when you're this close to the driver. So it's kind of a catch-22. You can't get past one without the other. You can't separate one without the other. That trying to measure noise floor in a room it's almost impossible. When you turn on your air conditioner or your heater in the room, that may be at 55 decibels or louder, and you're trying to measure something that's at 45 or 50 dB. It's just not going to happen. You can, let's say you have a refrigerator running in another part of your house, or just a computer, as we have in here. We have some computers running. Those are going to easily be 50 decibels. And again, it's just impossible to measure that stuff. And the distortion measurements really don't tell you anything about how a driver's going to sound or how a speaker's going to sound. It's a tool. It's a way of seeing if there's a problem, but it doesn't tell you how it sounds. And I've gotten into debates online with some of these people that they want to believe that lower distortion number, whether it's 1% to 2%, that you're going to hear a better quality sound out of that 1% than you would if it were 2%. So at one point I set up one of our 5 1/4 inch drivers, put it in a cabinet, 1 watt, 1 meter industry standard, took some measurements and plotted 2nd, 3rd, 4th, and 5th harmonics, and looked at those distortion measurements and saved each of them. And then I did the exact same measurement with the driver not playing. In other words, I took the frequency response measurement, looked at the 2nd, 3rd, 4th, and 5th harmonics that were of the ambient room noise. And I posted those, and I told the guys, I'll say, tell me then about what this driver sounds like versus what this driver sounds like. Which one is going to sound better based on the measurements you see? Of course, they didn't know that in this case, only one set of measurements had an actual driver playing. The other was just room noise. And of course, the levels that you see were pretty close to the same. The one that was actually playing had a little higher distortion, was within some areas, but overall you could almost track the distortion that you'd see from the room noise compared to the actual driver playing, and see that a lot of it was in the same place. So a lot of the distortion numbers you saw from the actual driver was actually room noise. And at the end, after some of these guys decided they wanted to tell me which driver sounded better, and all this information from these distortion measurements, I then had to tell them the truth in that only one of the measurements had an actual driver playing. The other measurement was just ambient room noise, which is impossible to separate those distortion numbers from. So with egg on their face, they kind of got the point. And I can't stress enough to you guys, there's no industry standard in measuring distortion. Whether one guy's measuring in one room versus another room, you can't really compare what one person thinks they've measured versus another. Same situation, same room. Using a near field technique, you can get some information and do some comparison from one driver to the other. But again, you're only going to see if there's a problem. You're not going to measure something that's going to tell you how it's going to sound. those distortion numbers are so far down in the playback of your music, it's very little of what you're hearing. So it's not much of a measuring stick. So those are my two that I want to, I feel like kind of pet peeves of mine. High power handling, low distortion. Those two are the two measurements. Just cross off your list. That's not going to tell you anything about how a speaker is going to sound. In the next segment, we're going to look at actual speaker measurements and learn to interpret them, how to read them, and learn which ones really tell you the most about how a speaker sounds. Tune in for the next one. Thanks for coming, or thanks for dropping in. See you guys next week.